can be used instead of using a heavier, large, slow-speed reversible engine, right? Reversible engine usually refers to larger engines, okay, which is usually used for fixed-pitch propellers. Okay? And because you are using non-reversible engine, so you have a chance to use a lower-cost medium-speed engine, right? And even together with the reduction gear package and CPP, the low-cost engine system is still a lot more cheaper than having a two-stroke slow-speed diesel engine, right? Which is like a small cathedral size, right? 4-story high, and the width is bigger than the room, right? So that's a very, very expensive piece of machinery. Okay, and very, very importantly, blades on the CPP can be individually replaced in case any one of them suffers any damage, right? Whereas fixed-pitch propeller, you got to remove the whole propeller for repair, right? Okay. Engine required to be started only one time, right? You only require the engine to be started only one time. For CPP, because CPP uses the angle of the blade, right, for moving the ship, give either thrust in either direction, right? But if the blade angles are at 0 or middle position, there's no thrust either direction, so the ship is not going anywhere even with the propeller turning. Okay, so the engine you don't need to reverse, right? Because you don't have to reverse the engine, so the engine you don't have to keep stopping the engine to reverse the rotation of the propeller, because CPP you don't need to reverse the rotation of the propeller, right? All you need to change will be the blade angle either from positive direction or negative direction. So positive generally refers to moving the ship ahead, negative moving the ship astern, right? 0 to 100%. So let's say 100%, the blade angle is, say, let's say 40 degrees is considered 100%. So from 0 to 40%, 40 degrees. So 0 to 40 degrees. So if 40 degrees, 100% of the movement, 50% would be 20 degrees, right, in the ahead direction or in the astern direction. Okay. So in case of power failure, controls of the CPP will move it to full ahead. Well, this is considered an advantage because let's say if the CPP is still turning, right, and there's some function, some fault in the system, hydraulic system, and the blade cannot be controlled. And once that is detected, the system will trigger to make sure that the hydraulic system is cut off. So if the hydraulic system is cut off, the internal mechanism, which normally there will be some powerful springs involved, the blades all will move into the 100% ahead direction, right? And why is that required? And why is that a good thing? Because a ship cannot steer if there is no thrust coming out from the propeller. Okay. So you need that thrust in order to steer the ship. So if the ship is not moving, you can't steer the ship, right? So the ship got to be moving in order for the rudder to be effective. Okay, so you got all these advantages. You only need 5. Okay. Okay. All good so far. Can I just check that all you guys are still able to hear me and see me so far? Could you guys confirm you guys are still seeing me on camera and you can still hear me? One of you, could you confirm that? In case I have some connection issues here. Okay, Soumya, thanks. Yeah, Jin Chen, thank you. Okay, I continue with my slides. Okay, what are 3 problems of intermediate shaft bearings? No more, no less. We only have three problems. We talk about that. Three problems of intermediate shaft bearings, and include one possible reason for each problem. So there's a difference between problem and reason. Okay, every problem has one or more reasons. Okay, so that's what this is all about. Okay, so it's there in your slides. So one of the problem, of course, is lubrication failure, right? So lubrication failure is a problem. Reasons, any one of those reasons below, right? Could be insufficient oil, that's one reason. Contaminated oil, another one reason. Incorrect oil use, right? So the type of oil used in shafting system normally is the same, normally similar to the main engine lube oil, right? Another reason could be failure of lube oil supply mechanism. Remember, intermediate shaft bearing, there is a floating ring that runs around, collects oil from the oil sump and bring it up to the top, and there's a deflector there that spreads the oil around the shaft, and the oil will be squeezed into the bearing, right? Okay. Or could be cooling water failure also, cooling water problem, right? Either too much of cooling water or too little cooling water, right? You know that the oil will get heated up in time, over time, right? So many reasons to choose from, okay? All you need to know is one of them. Okay, next problem is overloading. So overloading is a problem, right? And what is it caused? Of course, it's caused by misalignment. Overloading, 99.9% is caused by misalignment. And misalignment is, what are the reasons for misalignment? Okay, could be a local fire. Local fire means a fire that's near to the intermediate shaft bearing, right? Could be intermediate shaft itself. Could be grounding of the ship. Grounding of the ship where something is pressing against the bottom of the ship and making the ship hog, right? Sagging, hogging, extreme sagging, hogging of the ship that could be experienced in rough weather, for example, or improper loading of the cargo, right? Extreme hogging and sagging, okay, of the ship structure. That's going to contribute to misalignment, which will cause the overloading of the intermediate bearing. Okay, it could be thermal expansion and contraction generally experience, right? Thermal expansion, contraction of the ship's hull, for example, right, could contribute a little bit to misalignment also, which will cause overloading. A weakening of the hull structure. Generally, it's the hull structure below, right, below the intermediate shaft bearing. So that normally applies to older ships, ships maybe 15 years, 10 years, 20-year-old ship, right? And this weakening of the hull structure usually is due to corrosion, right? Corrosion, or could be due to grounding also, right? But generally, it's due to corrosion over the years, right? So you got two problems and so many of the reasons to pick from for each of these problems. Last but not the least, should be the last, right? Okay, so you only have three problems here. Next problem is metal failure. So metal failure is a problem, and metal failure could be metal failure of the structure of the bearing, or could be the hull structure, right? So these usually caused by fatigue. And what is the reason for fatigue? By vibration and corrosion, right? Could be due to corrosion, or could be long-term vibration, right? And after a while, fatigue sets in, and that could disrupt the molecular structure of the metal, whether it's the bearing housing, the bearing itself, or the hull structure. All right. Okay. So metal failure is a problem. Fatigue caused by friction, not friction, vibration. Fatigue caused by vibration and corrosion would be the reason. Okay. All right. Got it. Three problems. Each one of them has all the reasons for you to choose. Okay. Next, what is a stern tube? We've done that quite recently also, right? What is a stern tube? And the other part is these 5 advantages of oil lubricated stern tubes. And that usually means the 5 advantages of oil lubricated stern tubes over water lubricated stern tips. So oil lubricated stern tips are more advantageous. Quite a lot. You need to know at least 5. Okay, again is in the slides. So there's a description of a stern tube basically, right? 4 points there. You can paraphrase it. So it's a tube that houses and supports the propeller shaft with bearing surfaces, right? Houses and supports the propeller shaft with bearing surface. That last bit is very important, right? With bearing surfaces. Okay. Second point is fitted at the bottom section of the aft peak tank, right? Bottom section of the aft peak tank. That's to give you an idea where is it, right? So cast iron material is usually used to construct the stern tube, and it is fitted between the boss of the stern frame, and the aft peak or after peak bulkhead at the forward end of the aft peak, right? So in between you have the stern tube going through. And it prevents seawater from entering the engine room with special sealing arrangement. That's one of the most important things, right? Because you got a shaft protruding out of the hull at the stern, water try to get in. So you have some special sealing arrangement to prevent that. Okay. So once again, the tube houses support the propeller shaft with bearing surfaces fitted at the bottom section of the aft peak tank. Cast iron material prevents seawater from entry into the engine room with special sealing arrangement. Okay, so you can paraphrase it. But this is what you need to describe a stern tube. Okay, 5 advantages. How many? You have 7 to choose from. Okay, advantages compared with water lubricated stern tubes. Oil is a better lubricant than water. That's logical, right? Obvious also. Lower coefficient of friction, that means it will cause less wear and tear as compared with water lubricated stern tube. Wear and tear of both the shaft and the bearing. And white metal bearings can be used in oil lubricated stern tube because oil lubricated stern tube, basically we are using bush bearing, right? Metallic bush bearing, and with a layer of white metal. So these kind of bearings or bush bearings allow for higher loading, right? Higher loading, you can support more weight and you can subject to more stresses. Okay. Bearing surface is also reduced, which is a good thing. I explained in class also. If you are using bush bearings, right, metallic bush bearing with white metal, the bearing surfaces can be reduced. So of course, you've got a longer aft bearing, shorter forward bearing, right? But the bearing surface need not extend the whole length of the stern tube. So that is a good thing because you leave one big section of the stern tube without bearing surface. And that's why is it a good thing? Because remember, the tail shaft will always have some bending, right? Bending stress due to the weight of the propeller. This bending you cannot prevent unless you can manufacture a slightly kind of curved kind of bearing, right, or stern tube bearing. It's not possible to manufacture, right? So otherwise, if you have a long, completely straight bearing, this middle part of the propeller shaft that has excessive bending will have will act harder on the bearing on top, right? So this will kind of like damage the bearing and will lead to overheating also, right? So you allow more flexible by having smaller bearing surfaces. So you got more room for this propeller shaft to flex a little bit, which is a natural tendency due to the weight of the propeller. So that's why bearing surface reduced is an advantage. Additional bronze bush is not required. Water lubricated stern tube, your tail shaft needs to be completely fitted with bronze bush over the whole length of the stern tube. Water lubricated means seawater, which is corrosive in nature. So you don't want the corrosion to happen on the tail shaft. The tail shaft is very expensive, right? So you want to protect the tail shaft by having a bronze bush. You put a bronze bush over the entire length of the propeller shaft that goes through the stern tube. So this bronze bush will prevent the seawater from coming in contact with the tail shaft, actual tail shaft surface. So you protect the tail shaft surface from corrosion due to seawater. Okay, and abrasive particles of seawater not found in stern tube in the case of oil lubricated, right? So water lubricated stern tube, inside seawater, sometimes a lot of the particles are not visible to eye, right? You can't see it, but it's there. And all these small little particles in the seawater comes from where? All kinds of things, right? Dead animal, bones disintegrating, corals, a lot of small particles, hard particles come from corals, come from anywhere. Could be garbage, could be any rubbish, whatever, right? So all these small hard particles it's all they're always present in water lubricated stern tube. They're part of the wear and tear of the tail shaft and the water lubricated stern tube bearings. Part of the wear and tear comes from all these small hard particles. So oil lubricated stern tube is an internal thing, right? So it's not exposed to any seawater or dirt. So the lube oil is kept in a very, very clean environment. So you don't have all these hard particles going around. And oil provides higher vibration damping effect, right? Again, it's quite obvious, right? Oil, when you're bearing that's oil lubricated, you tend to have lesser vibration, right? Less noisy also, right? Due to that. So because it dampens some of the vibration, right? Oil because of its viscosity, and water can't do that because zero viscosity, right? Okay. Right, next, 4 types of checks during steering gear tests, right? Of course, this is provided there in the slide. And also there is a video, right? There's a video within Brightspace. You see this cadet, junior engineer, this young lady moving around, right? Doing all kinds of checks, showing you these, showing you thumbs up, all those, right? Okay, but anyway, it's all in these slides here. 4 types, at least you should know out of so many points, right? Steering gear test should be done within 12 hours before departure of the port by the ship's crew. Why within 12 hours? More than that, then they are not that, things can happen, right? Because certain things can go wrong within 12 hours, So you go more than that, you're increasing the risk of something happening. Of course, the best is to test a steering gear 1 to 2 hours before departure, right? But you can test slightly more than that, but not more than 12 hours. Visual inspection of the steering gear and all the connected linkages. Yeah, it's very important to check for any abnormal noises happening or abnormal leaks, right? And also, that's a time for you to check the levels of the hydraulic oil pumps and the reserve tank for topping up the pumps, right? And you want to test the communication equipment between the bridge and the steering gear compartment. Usually is by telephone, right? That has to be confirmed. Test the power unit failure alarms, right? They're going to turn off the power from the steering gear, and the alarms must be activated on the bridge. Okay. Full movement of the rudder from port to starboard. That's one of the first things you do when you do steering gear test, right? 35 degrees on one side to 35 degrees on the other side, and reverse. The same way must be able to be done, right? And the rudder angle will be shown on the steering gear local indicator, and that must be corresponding with the rudder angle indicator on the bridge. So if it's showing 21 degrees port, the bridge must also show 21 degrees port. Or is it showing like 35 degrees? No, usually not, right? Maximum is 30. So let's say 28 degrees. 28 degrees to the starboard. So on the bridge, it should also show 28 degrees. All right. Okay, and of course, you want to test the control of the steering gear locally and from the navigation bridge. So you switch between the bridge control, steering, and switch to local also. There's a local mode for steering the steering gear for controlling the steering gear from inside the steering gear compartment. Okay, so many to choose from. Okay, the next part of this slide here lists any disadvantages of rotary vane. In case of any abnormal operation, right, or abnormalities, wear and tear will be more than the RAM system, right, and it cannot take vertical movement, right, because it's all tightly packed within a round cylinder, right, and vertical movement, it comes from where? Basically, it comes from the flotation of the rudder, right? The rudder is actually floating. It's hollow inside the rudder. So rudder can move up and down a little bit, right? So rotary vane cannot take those kind, right? So anything moving up and down, you have additional force acting inside the rotary vane, system itself, the structure. And rotary vane, because it has some seals, right? In fact, a lot of seals, right, to seal the edge of the vane, right, against the body or the casing. So because you cannot see what is inside, right, it's totally enclosed. So this seal failure normally can be higher, right? Normally it's higher than the seal of the RAM system. Seal of RAM system more straightforward, right? So this has a lot of movement, right? A lot of movement between the vane, the movable vane and the fixed vane, and the casing itself. So there's a lot of wear and tear normally, right, as compared with vanes, what do you call that, RAM system. Okay, right. Okay, and basically it's the testing part here that you need to know at least 4, and the rotary vane system disadvantages, you need to know at least 3. Okay, pilgrim nut. How do you use a pilgrim nut to secure propeller? Here, the keyword is not pilgrim nut. That's very obvious. But the keyword here is secure, right? Because in your knots, you have secure and you have removal of propeller using the same pilgrim nut, right? But here, we are talking about secure, right? Secure means install the propeller onto the tail shaft. So these will be the things that you need to talk about. Okay, so you have to not everything here you need to talk about, but you have to start talking about from point number 2. Right? Point number 2, nut refers to the pilgrim nut, and you are only talking about the top half of this diagram. The bottom half is how you use the pilgrim nut to remove the propeller, but to secure it is this top half here. Okay, so first you want to start the first point. The nut first screwed on to flush against the propeller boss, the vertical surface of the propeller boss. Hydraulic connections are made. You connect a hydraulic line here to the hydraulic pump, and the pressure of the hydraulic oil raised according to the specification given by the propeller manufacturer, right? And the loading ring, right, in the face of the pilgrim nut that's resting on the propeller boss, there is a loading ring that is going to protrude out due to hydraulic oil pressure from within, right? So this tendency of this loading ring moving out is the loading ring is going to push onto the propeller, push it to ride it up the taper of the tail shaft, right? And then when propeller is tight and has traveled the required distance up the taper, hydraulic pressure is reduced, right, from the pilgrim nut. So when the propeller has moved until it cannot move anymore, given the the pressure of the hydraulic oil, and that is deemed to be enough. Right? Then after that, the propeller, no, because after the loading ring has pushed the propeller against the taper here, there will be a gap right between the surface of the propeller boss and the surface of the pilgrim nut. So the pilgrim nut, you don't remove it and put it in the ship store, right? Because it's a heavy thing, so you leave it there, and you just need to turn the nut until it comes flush against the propeller boss. And there are quite a number of threaded holes on the propeller boss where you can fix a number of brackets, those L brackets, to secure the propeller onto the in position, right? So that the propeller nut will not loosen itself and then drops into the sea, right? Into the seabed. Okay, so you leave the propeller or the pilgrim nut on the shaft here, but you fix it with little brackets, right, to prevent from dropping off, and then you leave it there, right, and then you're going to attach a cone shape end here over that, right, and you're going to tighten it. So this pilgrim nut here, after tightening the propeller against the tail shaft, the job is done. But you want to leave it there, right, and store it at the propeller. Okay, so when propeller is tight and has traveled the required distance up the taper, hydraulic pressure release. Now the ball grips the taper by friction grip. Okay, right. So all these points here, 2, 3, 4, 5, 6, and at the last bit also. Okay, so that's the method. Type semi-built. Okay, so we got fully built, we got semi-built. In the semi-built type, the features will be the web and crank pins are fabricated as one unit and string fitted or strung onto the journal. Crank pin and the and the crank web, they are manufactured out of the same material. So obviously this cannot be a very large engine, right? Okay, lastly here is one-piece crankshaft. This is the last type, one-piece crankshaft, and features usually drop forged as a single piece, and normally used in high-speed engines only, right? Because this very, very short crankshaft, maybe not longer than my fingertip to fingertip, right? So these are usually used for high-speed engines. All right. Okay, next, with a simple sketch. Simple sketch, you'll be able to do in like 2-3 minutes, right? Illustrate the different forces acting on the crankshaft during operation. So it involves sketching and labeling, right? So remember this. Sketch this in class also. So it took me about 1.5 minutes. Another half minute to put down all the labels, right? So once again, I'm going to show you how simple to do this, right? So you just do a couple of shoe boxes, right? Roughly around that kind of angle. Right? Shoe box number 1. Another shoe box behind, right? So you want to be more professional. Continue this line here. This line is going to continue here. So they are the same size. Both shoe boxes are the same size. This one also, this line going to continue here. Okay. Then you're going to add on, this will be the two crank webs. And I'm going to add on the journal on this side. So I'm going to like draw a circle here or a slight elliptical. And then the two lines here, same angle as this. Okay. Can make it a cylinder also, it's okay. But don't forget to erase the lines inside. So using a pencil will be good. You can erase off. So this looks like a journal now. I should have one more journal on the other side of the crank web, right? So about the same, go up here. Same angle, and go up here. Okay, so round it off here. Journal on the other side. I want to add in the crank pin, right? Crank pin, so I have another circle here. Crank pin have two lines here. And of course, I erase off. So this is a crank pin, right? As inserted or part is going to be attached to this crank web and this crank web. Okay, and then I'm going to add on the forces, right? The different forces coming down. Okay, so one of the forces from the connecting rod coming down to the crank pin, right? Forces from the connecting rod, right? I'm using short form. And then because of this force coming from the connecting rod, you have bending, right? Bending force of the crank pin. So how do I represent bending force? I'm going to put two lines here, one line here, and then an arrow here, right? So this is to represent bending force of the crank pin. Okay. So if the crank pin tends to bend a little bit, the crank web experience twisting, right? Twisting. So I'm going to draw a center line out of this crank web. Okay. And then I'm going to do this circular arrow here, right? To show that this crank pin will tend to twist when the force from the connecting rod is coming down, right? And of course, the other side will tend to twist the other way, inwards. Okay, I only need to show one, right? So here I'm going to call it like twisting of the crank web, right? Twisting of the crank web. Okay, bending of the crank pin. This is the one, right? Then I also have this, because of this cantilever effect here, the force coming down here, so I have a bending of the crank web also. So how do I do bending of the crank? I just put an arrow here, right? We'll draw a line here and put an arrow here. Okay. So here, this is bending of the crank web. Okay. And last but not the least, this will cause this journal to rotate, right? So this rotate is always the torsional force, torsion of the journal. Okay, so you have 5 forces acting here on the crankshaft. And of course, that's a simple sketch. So you can do that. I did that by everything a couple of minutes, right? Okay, so that's what you need to do. Again, you guys have been practicing about 59 times already, right? Okay, next, you add on these labelings. Okay, torsional vibrations in slow-speed diesel engines are addressed by what kind of thing, right? Torsional vibrations, slow-speed diesel engine, only slow-speed diesel engine are fitted with all these things, right? Torsional vibrations to be addressed using a vibration damper, right? Vibration damper, or sometimes it's also known as detuner, all right? Okay, give me just 1 minute. Connect my power supply, right? Okay, power supply on. Okay, so torsional vibration addressed by vibration damper, okay, vibration damper or a detuner. Okay, okay, pretty straightforward there. Okay, next, what is the equipment below, right? So you're going to see this diagram given to you. Equipment below, firstly, you're going to call it intermediate shaft bearing, right? Okay, it's okay if you call it just intermediate bearing. We all know.
You are currently the only person in this conference.
Okay, guys, I think I could have lost my connection a few minutes ago. Okay, yeah, thanks Zikri for telling me. Okay, connections here. Okay, so I'm going to go back one slide which I was talking about earlier on. Okay, you guys can see me and the slide. Can hear me also right now. Good. Okay, a few more slides, then we are done. Right? Okay. Can you guys confirm? One of you, you can see me and hear me and the slide also. Okay, thanks, Yu Tong. Okay, I'm going to go back to the previous slide. Previous slide I was talking about this, right? Torsional vibrations, and the one before that I was talking about, of course, the sketch about this crankshaft thing and the 5 different forces. Okay, I was saying that you guys must have been practicing this for about 59 times already. Okay, and then torsional vibrations are addressed by vibration damper or detuner. Then when I move here, kind of like I lost connection. Okay, so this is the diagram here, which you want to identify what equipment is this. Of course, this is the intermediate shaft bearing, or you can just call it intermediate bearing. Same thing, right? Now, do not call this a truss bearing, right? Just because it looks like some kind of bearing. So don't just call it the wrong thing, right? So it can only mean intermediate shaft bearing or intermediate bearing, okay? I don't call this a stern tube, don't call this there was one batch identified this as don't know, some kind of pump, some kind of pump or some kind of compressor. Can you imagine? Okay, so number 1, 2, 3, 4, 5, 6, we've done that. Remember, we've done that in the weekly quiz. Number 1, of course, is the housing. You can call it the casing also. Number 2, follow the arrow. It goes right at the bottom here. So that's a sump or oil sump. Okay, if you want to decide to call it oil reservoir, that's fine too, right? Okay, side glass. Number 3, call it gauge glass, level indicator, same thing, right? They are all correct. Drain cork, drain valve, they are all correct, right? This to drain the water inside the cooling coil. Number 5 can only be called deflector. I don't think there's another name for it, right? Deflector. Scraping plate doesn't sound that nice, right? So stick to deflector, all right, guys? 6, of course, it is the lubricating ring. No other way to describe, right? Lubricating ring. Number 6. Number 7 is the intermediate shaft itself, right? So if you name the equipment wrongly, by the time you get here, suddenly you remember, oh, this is an intermediate shaft, so this has to be the intermediate shaft bearing, right? You get what I'm trying to say, right? Okay, last but not the least is white metal bearing. This darker shaded part here. You see the arrow, number 8 goes all the way here. So it's the white metal bearing, okay? Or you want to call it bare-bit bearing also, bare-bit, B-A-B-B-I-T. Just don't misspell it as rabbit, okay? You know, call white metal bare-bit. Yeah, that's a correct name also. Bare-bit. Okay, next, how the lubricating mechanism works, right? In the equipment previously, in the previous slide, so which is the intermediate bearing. So we are talking about the lubricating ring, right? So this is how you describe it, right? When shaft rotates, lubricating rings get rotated. Same thing, if you know how to answer this, suddenly you go back and check, or you label the lubricating ring incorrectly. So you go there and change it, right? The lubricating ring. Okay, next, rotation of the lubricating ring carries the lube oil to the top. Lube oil, you can spell it as L-U-B or L-U-B-E, that's fine, right? Carries the lube oil to the top. Deflector, here, again, if you name it incorrectly, suddenly you know how to say deflector here, you go back and correct it, right? Deflector helps to spread the oil over the shaft and bearing. This is called splash lubrication. And actually, just the 3 first bullets describe the lubricating mechanism, right? How it works. You don't even need to talk about the last point here. Drain valve, fitted, dipstick, or side glass to display lube oil level, cooling water coils of copper, or whatever. So don't have to say the last point, right? The first 3 points fully describe the lubricating mechanism, how it works in the intermediate shaft bearing. Okay, so when shaft rotates, lubricating rings get rotated. So you got to imagine in your mind, right? So rotating, lubricating carries the lube oil from the sump to the top, and the deflector helps to spread the oil over the shaft and the bearing. That's all you need. Okay. Okay, but you got to be in that order. Don't reverse it. Then means the same. It means differently already. Okay, so you got to be in that order. 1, 2, 3. This system, of course, not required to sketch. Identify what's the system here. Of course, it's an oil lubricated stern tube. All right. So you got to be quite specific. Oil lubricated stern tube. All right. And of course, number 1 is the header tank for stern tube. Number 2, forward seal header tank for aft seal. That is number 3. So you know, if you know this header tank for aft seal, you follow here. Of course, number 7 is the aft seal, right? In case you call this tank incorrectly, then by the time you get to 7, you know that is the aft seal. Slowly, you got to go back to number 3 to correct, right? Header tank for aft seal. Okay, forward bearing, the bearing at the forward end. Of course, the propeller is at the aft end, so this is the forward end, right? So forward bearing. If this forward bearing, number 6 must be aft bearing, right? So, but let's answer number 5 first. That's a sump or oil sump. Okay. Aft bearing, right? This forward bearing, this must be the aft bearing. Okay, and aft bearing, yeah, bearing you can spell it B-R-G. Okay, don't spell B-G. Just spell B-R-G. That's the shortest you can get, right, of bearing. Okay, I've done that in your quiz as well. Most of you get it right anyway, right, in the quiz. Okay, now the second part of this system here, okay. Refer to the picture in the previous slide, which is this. State the functional purpose of component 1, component 7, and component X, okay. So again, we have done it. Component 1, which is the header tank for stern tube, creates adequate lube oil pressure to counter the effects of hydrostatic pressure of the seawater outside, right? So there is enough pressure. The pressure inside the stern tube is slightly higher than the seawater hydrostatic pressure outside, right? So that no chance of water entering the stern tube, and maybe if it's not very tight here, a little bit of oil may leak into the sea, right? But there's a better option than rather having water inside here and damaging the bearing and the tail shaft. All right. Okay, the job of component 7 is an aft seal. The job is to prevent entry of seawater and dirt into the stern tube, and the other way is also required, prevent leakage of oil into the sea as well, right? So that's what the set of stern aft seal is supposed to do. Okay, and last but not the least, again, X. Component X is a valve, or you can call it a bypass valve, and all you need to do is say to be open for ballast condition and closed for full draft condition or full loaded condition. Okay. So that's it. That's what these three components are and what they are there for. Okay, what is the type of truss block that features inventor's name? Done there also, right? The inventors, of course, is Tony Mitchell or Anthony Mitchell, and the type of truss block is tilting pad type. Okay, tilting pad, or the name itself, Mitchell truss block, right? Mitchell truss block. Okay, and use a simple sketch to explain how the wedge type oil lubrication works in this kind of bearings, right? Tilting pad bearings. So this is the picture you're going to be familiar with, right? And with all these tags there, okay? Notice the arrow or rotation. So the truss is the truss from propeller. So this is a truss collar. So, and this oil wedge here, okay, you got to do something which is slightly different color than the rest, so that is represented there, right? This triangle is very important, the yellow triangle, okay? So you can just draw a triangle there, right? Maybe you can put a triangle with a few dots inside, right? Triangle. Represent the oil. This is oil wedge. Okay. Of course, you got to have these truss collar, right? Direction of rotation, truss collar, and then you have this housing there, right? And of course, this little angle here, you're going to sketch this thing also, right? Okay. And housing here. Okay. And this one you straight it this way. Okay. So this is a tilting pad. Okay. And this oil wedge here is very, very important. Okay, oil wedge. Okay. Right. Stationary housing. This is a stationary housing. And of course, there's the tilting pad there, right? Tilting pad. And this is the truss collar, direction of rotation. So these basically tell, oh, don't forget the truss force on the propeller. Okay, so this diagram represents your understanding of how the oil wedge lubrication system works for tilting pad type of bearing. Okay, couple of minutes there. Okay, truss block. Why are truss block usually positioned next to the propulsion machinery, right? Just the aft of the main engine usually. So there's a reason here, right? Okay, sited just next or close to the propulsion machinery, because the effects of differential expansion of the hull shaft and the hull is reduced, right? Because the hull structure below the main propulsion machinery, which is usually the main engine, the hull structure below the main engine is very, very rigid in order to protect the engine, right? That's where the engine rests, such a heavy piece of machinery. So the hull below, directly below the engine must be very, very sturdy. and position the truss block near there. You're taking advantage of the sturdy construction of the structure below the engine. Okay, that makes it a good way to put the truss block there. Because what's the purpose of truss block? Is to distribute the force from the propeller shaft, right? The thrust from the propeller to the hull, right? So the part that the truss block rests on going to be very sturdy as well. And by positioning it nearer to the engine means you're further away from the tail shaft, right? So the tail shaft, you have this whirl of tail shaft. It's been whirl before. Whirl is the tail shaft tend to do this, right? Say this is the propeller here, the forward end of the tail shaft tend to do this. So this is no good for the truss block to be there, right? And the first point, the third point, they are all related, right? The heavy construction of the double bottom structure under the main propulsion provides ideal foundation, and it reduces the effect of differential expansion of the shaft and hull because of that, right? So these are the 3 points you need to talk about. Okay, truss block. Okay, guys, question? Any question, guys? So far, any question at all? Okay, Daryl say no. Okay, any more before we end this all-important revision session? If no question, page 26. Soumya say page 26, last page. Okay, I'm gonna go to here. Okay, I'm gonna keep it here for a while. Question, Soumya. That's page 26. Tilting pad truss block. Okay. Then I'll leave it there for a while. Or you have some questions for me? Okay. Soumya is typing. Let's see. Okay, many things you've done in the quizzes. So the answer, Soumya say what? So the answer will be either tilting pad or Mitchell truss block. Yeah, of course, right? This is the first part of the question here. What is the type of truss block that features the inventor's name? So you can write tilting pad type or Mitchell truss block. Yes, either way. Okay. Right. Any more questions, guys? Any more from anyone else? Okay, if not, I'll be here for a couple more minutes, right, in case anyone has any question. Okay, otherwise, good luck to everybody, and study hard and be the best you can be. All right, okay. So give it your best shot, and definitely you can do it, right, with some practice. So go ahead and practice some of these things here, and stay healthy as well, right? Because if you fall sick, then that's going to affect your revision. So stay healthy, have a good rest, sleep well at night, eat well, okay, have good rest, and have a positive mind, right? And you guys will do really well. Okay, guys, we'll see you guys in our next phase. And